I will not keep this hand. Put root on the bottom. Let's go. Good morning, everybody. Just playing little cards. I'm waiting on getting started. What we're doing today? Number of possible answers. I gotta take my turn. 1 second. Let me crack this. An island. Is there? What's in there? Okay. Text. You didn't go make your beds. Wait on more people to show up. Okay. What should I do? I'm gonna growth spiral. Template to play. Don't need you right now. Play land and a druid and say go. Next turn is gonna be fun. Sure. I should just okay. Oh, nice. Okay. Well, let's spin the wheel. What do we get? What do we get? What do we get? Really? Ugh. Well, I guess I'll take you. And I'll get the passage back. Not the best Garuda, but oh well. What you got, opponent? So for those of you wondering on stream, this is called Magic the Gathering. It is all math. Yeah, huh. Oh, that's a good draw. Okay, crack you. Go get an island. Play Thassa. Bounce that guy. Don't need a growth spiral. Yep. Swing on. Bounce and go spin again. Oh, that was better. I saw a spark double. Copy Garuda, go again. And my opponent quits. Good game. We're going to get started with possible solutions here in about 5 minutes in case you need to go make your bed or take care of anything. And if not, you're going to play a little bit more Magic. Okay. Ugh. Um. Okay. It's not the best hand. If I draw land, I'll grow spiral. If I don't draw land, I'm gonna Buffalo Haven. See what happens. Tapped. Wow. Apparently my opponent didn't draw what he liked. Good game. Mm-hmm. Yeah, that's key. Sure. Okay, let's try to get a land. No, I need a land. That's a land. Oh, they're playing Gerudo too, so this game might end. Let's see. Let's land. Let's go and play you. Pay the 2 life. Go get more lands. Looks like I'm gonna win the race to Garuda. Your turn. What you got, opponent? Yeah, he's playing like the exact same cards we are. Oh, he's going with some elementals. Okay. 1, 2, 3, 4, 5, 6. I already have the mana. I guess I can play you tap. Slam Gruda. I am going to take your Charming Prince. I'm going to bounce my own Gruda. He comes back into play. I spin the wheel again. What do I get? What I get? What I get? Oh, I believe I'm going to take your aggressive mammoth. 1, 2, 3, 4, 5, 6. Okay, now he can play his Gruda. See what he gets. Did he get a Thassa? Sparta. What do you get? Now this is like an interesting mirror match because he's getting spark double after spark double after spark double. He's got 30 cards left. I've got 28. He's gonna go again. Mirror match. Yeah, him getting multiple spark doubles was better than me getting a mammoth. So okay, I can bounce stuff. I'm not really sure that helps right now. Okay, so I need to bounce her back to my hand. Oh, that's kind of a cool draw. I have to get it back though. I have to wait a turn. So I dropped the Thassa. No attacks. I bounced my gorilla. I need. Can I get calm? Let's get another Charming Prince. Let's go again. This is the most ridiculous match ever. We're gonna get started with real math here in just a second. Okay. This is so dumb. But he's one out on his spins. He's got more Gerudas than I do, and he's got the worm doesn't have trample. He needs the mammoth for that. Okay, let's see what you're doing. Oh, what did he do to my Geruda? Where'd you go? Did he steal it somehow? Wasn't paying attention. He tapped this one down. Okay, so I'm going to end up losing a Charming Prince to block him, and I'm losing a Charming Prince to block him. I'm going to take a bunch. Spin that wheel. Ooh. I'm almost out of cards. What do I do? Okay, I can bounce him. Doesn't even matter. Okay, he's at 22. If I go down to 3, 1, 2, I tap you, I tap you. Do I have the damage? I send them all. Do I win? This is where math counts. Yep, I think I win. Come on, man. Yes! Oh, man. That was stressful. Okay. Yay, ranked up. Like it matters. Okay. Well, thank you for being patient, everybody. Math is fun. Okay, so what we're really going to be getting into today is the number of possible solutions in a system. And before I really get into what the problems look like, I just need to give you guys a quick demo on what it is we're talking about. So listen up and watch carefully. So let's say you have and here's a y-axis, here's an x-axis. Okay, so we're making a graph, and let's say you had two different lines. So we have a line going this way, and we have a line going this way. Okay, so those two lines, there is going to be a spot right here. And this is called the solution. I'm doing green. Okay, this is important to understand. The solution to a system of equations is where the two lines cross. That means that if there is an answer where there's an x value and there's a y value, so the solution is the coordinate. Okay? So that's kind of paramount. You understand that the solution to a system of equations is an xy coordinate. Now, that being said, your sometimes, like in this system, there's one answer. There's one xy coordinate, which is great. Now, in other situations, let me erase a little bit. So hang on, let me go ahead and make a list of our possible answers for today. So sometimes there's one solution. Now, if I erase some of this, based on what I just said, let me put my y-axis back. Okay, so now, sometimes those lines are going the exact same direction, they have the exact same slope, and you might notice they are never going to cross. And if they are never going to cross, there is no solution. So one of our options is going to be that there is no solution, meaning there is no x, there is no y, there is no point in the coordinate grid system where the two lines ever meet. Okay? The third one is a little bit weird. So let's say your first line is going through the system like this, and your second line is exactly on top of that line. Well, if that's the case, then the x and y's it does not matter which x value you choose. There is always going to be a y value that matches because they're the exact same line. And that's just basically all you need to understand. They're the exact same line. They are the same. Get that in orange. And let me move the typing over here so it doesn't get put on your pictures. Okay, so if they are the same line, basically what we're saying there is that there's infinite solutions. Because every single x and every single y all produce answers, okay? So that's basically the theme of today, is that sometimes we have one answer, sometimes we don't have any answers, and sometimes we'll have infinite answers, just depending on how the equations are written, okay? So that's the visual demo. But what is that going to look like for us when we're actually figuring out these problems? Well, here's what it's going to look like. Let me get rid of the picture and keep our possible answers. Okay, so what it's going to look like on your paper and for me, if we get one solution, what that means is we'll have something like x equals 4. Like we will come out with an answer, something of this measure. X equals 4, y equals 7. We'll have something like that. That will tell us that, oh, when x is equal to 4, these two lines cross. Okay. What it's going to look like for us if we have a no solution system, that means we'll end up doing all our math and we'll get something like 12 equals 5. Something impossible. That's something that does not make sense. That's the case when we have a no solution. They are parallel lines. They will never cross each other. What's going to look like for us on paper for infinite solutions is we'll get something that is always true, like 9 equals 9. So these are the clues that tell us that we either have a system that has one exact answer, no answers because they have the exact same slope and they're parallel, or infinite answers because this is an always true statement. Okay, so that's the lesson sort of in abstract. Let's go ahead and see what this looks like in real problems. Yeah, Chad, that's that's the second one you sent me an image of. That's the one we're gonna be. Yeah, those are the exact same problems we're doing today. It would help immensely if I would stop closing the exact window I'm trying to open. Had it all ready. Okay, here we go. Okay. Finally. So now, they're not going to give us the image here. Instead, they're going to give us the two equations side by side style. So where are my math practice standards? High level production today. There they are. Okay. We need to make sense of this problem real quick. Okay, so what they've basically done here is they started with two equations which were, give me a line, okay. They started with y equals 5x plus 8 minus 7x, and they had y equals negative 4x plus 1. And what they did is, since they are both equal to y, like these were the two lines on their graph somewhere, well, since they're both equal to y, they can set them equal to each other. And they've taken that step out and they're just letting you start from this position. So what we're going to do is we're going to figure out what x is equal to, and based on how it turns out, we'll know if it's got no solutions, one solution, or infinite solutions. So here's what you need to do on your paper. First of all, write out this equation, and I'll do the same. So we've got 5x plus 8 minus 7x equals negative 4x plus 1. 5x plus 8 minus 7x equals negative 4x plus 1. Okay. Da, 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 da. So the first thing I noticed is that I can combine like terms because I've got on one side of the equation I have a 5x and I have a negative 7x. So 5x minus 7x is going to be negative 2x. I still have plus 8 equals negative 4x plus 1. So all I've done so far is just combine like terms. But now we need to start doing some inverse operations. So if I were to add 4x onto both sides, let me scoot my math practice stands over here for a second. Okay, so just to be clear what we've done so far, we made sense of what's going on, and now we're starting to reason abstractly. And I'm going to say this once, and then for the rest of the stream, I'm not going to write this down, but the main things we're doing right now, the rules that we're abusing are that anything plus its opposite, anything plus its opposite is equal to 0. That's the first abstract rule we're totally abusing. And the other one is that anything divided by itself is equal to 1. So those are the two main abstracts we're going to be abusing a lot in these inverse operations. So let's go back to what we were doing. So if I'm adding 4x to this side, I have to also add 4x to this side. But why would I do that? Here's why. When I add an opposite, that's my abstract law, it makes a 0, or math teachers say it cancels out. So basically, I'm going to get my variables on the left side of the equation when I do this. And I'm going to do the same thing with these constants. And constant is the word that means the numbers with no letters attached to them. So if I take away 8 from both sides, then these opposites make a 0. So what we're left with after this chaos I've created, negative 2x plus 4x is just going to be a positive 2x. Negative 8 and positive 8 make 0. Negative 4x and 4x make 0. 1 plus a negative 8 is a negative 7. Now I can divide by 2 on both sides, because 2 divided by 2 is equal to 1, so I have 1x. So what we're left with is x equals negative 7/2. So we have just discovered that in this system, x comes out to be a thing, one place. So, and if you didn't notice, what I'm really doing here is I'm making my argument for what I think the answer is going to be. The structure I've been using, the equations and all my inverse operations, that's sort of my tool for today. I made my big model here. Okay, so now I'm going to bench my practice standards for just a bit. So because we came out to x equals thing, that means that in this system, there is exactly one solution, because when x is equal to negative 7/2, that's where you're going to have a y value, and that's where the two lines cross. So if it comes out to x equals anything, decimal, fraction, positive, negative, I don't care. If it comes out to anything, you know there's exactly one solution. And with some of these, you'll be able to spot it a mile away. Like you'll see as soon as you start moving the equation around, like, oh, this is going to come out to x equals something. Okay, let's try another one. Got to open it back up in a new window, though. So here are, again, this used to be two different lines, two different equations, and they've gone ahead and mashed them up. I kind of wish that the lesson had made you do that. I think it'd have been beneficial. So you know what? I'm going to do it just because I think it's important to understand how this started. So what I mean is, let me get some text going. Originally, this should have been y equals -9 parentheses z plus 8 in parentheses and y equals -9z minus 72. Okay, so what they've gone ahead and done for you is taken these two things and since they're both equal to y, they set them equal to each other. Like if they're both equal to the same thing, then they must be equal to each other. So they've done that. They've gone ahead and set them on either side of an equation where they're equal to each other. Now it's our job to examine this and see if there's no solutions, meaning we'll get a weird answer where something doesn't make sense, exactly one answer where z will equal something, or infinite answers where like we'll get 10 equals 10 or something. So let's go ahead and on our papers write it out. So -9 parentheses z plus 8 n parentheses equals -9 z minus 72. Well, the first thing I notice is that I don't have my math practice standards on screen. Okay. So we've made sense of the problem. Now we have to persevere in solving it. Gotcha. Okay. Okay, so a tool that we're going to use right now, well, I think it's a tool, is the distributive property. So we've got to take this -9, multiply it by the z and by the 8 because it's the coefficient. It's mashed up against these parentheses. So what is -9 times z? It would be -9z. And -9 times 8 would be -72 because positive times negative is a negative product. I still have this stuff on the other side, -9z minus 72. Oh, hello. Anybody notice something? If I'm not mistaken, those are the exact same thing. So what my brain just did is it kicked in with this repeated reasoning, math practice standard number 8. And I remember from the demo that I said, anytime you have something that is the exact same on either side, we know exactly which answer it is. So does anyone remember in chat? When we have the exact same thing on both sides, is that, let me move you. If we have the exact same thing on both sides, is that no solutions, exactly one solution, or infinite solutions? Mm-hmm. When it's the exact same thing on both sides of the equation, that means you've got the lines are identical. They're the exact same thing. So that means you have infinite solutions because those two lines are on top of each other in the same direction. So every x value is always going to have a y value answer. Let's try another one. Okay, chat. Let's see if you can get this one right without much help from me. Well, let's see what happens anyway. So what I want you to do is to write down this equation on your own paper, which is 3 parentheses y plus 9 n parentheses equals 12y plus 13. There it is. And go ahead and see if you can decide for yourself if this is going to have no solutions, one solution, or infinite solutions. Go, 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 go. Let me unmute myself before I start talking. Okay. Well, I'm going to start working and catch up to you guys and see what happens. So the first thing I notice I've got to do is this distributive property. This 3 has to get multiplied by the y, and it has to also get multiplied by the 9. So you'd end up with 3y plus 27 equals 12y plus 13. Okay, my brain is guessing we're going to have one solution. That's my guess. I'm going to prove it now, but that's my guess. So if we were to take away 3y from both sides, and if we were to take away 13 from both sides, those would make a 0. Those would make a 0. So what would we be left with? 27 minus 13 would be 14. And 12y minus 3y would be 9y. Then we can divide both sides by 9. And what you'd end up with is a very beautiful 14/9 is equal to y. Now, I don't really care if it comes out to an ugly fraction, improper, negative, anything, because if it comes out equal to something, that means that there's an answer, one answer. So if you do all the correct inverse operations and you come out to variable equals value, that means you found that there is one place where these two lines cross. Let's try another one. Okay. So they've gone ahead and helped you out by taking the two equations and mashing them next to each other. So go ahead and on your own paper, go ahead and write it out. That's negative 3x plus 9 minus 2x equals negative 12 minus 5x. Negative 3x plus 9 minus 2x equals negative 12 minus 5x. Okay. I can give you a hint here. If you want to solve this before I do or on your own for pride's sake, the first thing you're going to have to do is combine like terms. Then your inverse operations to, can I add a background to that? So it's easier to see. Apparently not. I can make it bold, but nothing more. Okay. So go ahead and see if you can get your answer. Yeah, chat, we're doing some that are exactly like the one you emailed me about. Okay, time for me to try and catch up. So the combining like terms that has to be done is right here. There's negative 3x and there's negative 2x. Now they're both negatives, so when you combine them, you're going to end up with something like negative 5x. I still have this plus 9. So that'd be equal to, I'm gonna rearrange these. I'm gonna say negative 5x minus 12. Let's commute the property of addition. Well, I mean, we're adding negative numbers, but still. I still have negative 5x, and I still have negative 12. You know what? Never mind. Let's not do that. It's going to confuse people. Okay. So I still have negative 12 minus 5x. Okay, so now let's do some inverse operations. So if I were to, we're going to have something funny happen. Watch this. So what if I add 5x to both sides? Well, negative 5x plus 5x, that makes 0. Negative 5x plus 5x, that makes 0. So we end up with 9 equals negative 12. Huh. Is it ever true that 9 equals negative 12? It can't happen. It's not possible. So which one of these answers are we supposed to go with when you get something like this that makes no sense? Sound off, Chad. Come on, wake up. Which one of these answers are we supposed to pick when the result, it just doesn't make any sense whatsoever? I mean, you haven't done anything wrong. You just get something that does, it's never true. That means that these two lines never, ever, ever cross. Now, for the more algebraic explanation, you might notice that right here, when we had both sides, the slopes of these lines was negative 5 for both. They both had the same slope. So that means that they'd be parallel lines. They'd be going down 5 over 1, down 5 over 1, down 5 over 1 forever. They were parallel. That's why they would never cross. That was a good one. I'm glad we got one of those answer types on stream today. Okay. This might be the last problem of the day, folks. I feel like we've had a good chunk. We've had exactly one solutions. We've had infinite solutions. We've had no solutions. So I think this is gonna be the one. So if you're in chat, if you're here presently, you guys, I need you guys to try this on your own. It's best for you. Then you can ask me questions. But here it is. We're starting with negative 25z plus 1 plus 35z equals 10z plus 1. I made the font bold. Now it takes up too much room. There we go. Negative 25z plus 1 plus 35z equals 10z plus 1. That's it. All right, well, we made sense of the problem, what we're doing. I need you guys to let your previous understanding kick in. Use the appropriate tools, which means use your equation and your inverse operations. Reason abstractly. It means when you're canceling stuff out, you're using those basic principles. Show me, just prove to yourself that you found the right answer and be precise. I'll give you about a minute head start. Okay, you've had your head start, so here I come. The first thing I see is that I'm going to combine like terms. I have a negative 25z and a 35z. And if I were to put those together, it'd be 35z minus 25z, so that'd be 10z. Plus 1 equals 10z plus 1. Yeah, I agree, chat. If you notice, 10z plus 1 is always equal to 10z plus 1. Therefore, what we have found is infinite solutions. Yep, that's how that works. So basically, we are doing the algebraic proof of whether or not two lines are ever going to cross once or never cross because they're parallel or cross all the time because they're the exact same line. And yeah, so I think what I'm going to do for just for funsies, in case you guys, have any last minute questions, I've gotten a couple emails with pictures of the assignments. So if there's anything unclear about the lesson, I'm going to hang for another couple minutes and get you guys' opinions. If you feel you got a handle on it, you are more than welcome to peace out. I think I'm going to play one more round of Magic before I get ready to post the replay for everybody. So here's your chance to ask questions while I multitask and try to win a card game. It's nice that some of the problems you're done really quickly because you realize that they're the same or there's no solution or there's one early on. And the more you guys do them, the more you'll get the hang of noticing ahead of time before having to do all the work out. Checking my email, see if there's any more requests. So far, I don't think so. For those of you that did post in problems for me to do, I hope that the work we did today does help. I don't want to actually do the ones you posted me because they are from your assignments, but some of those will show up anyway. Ew, do I keep this hand? That's turn 2. I need to draw land to hit that. All right, I'll keep this. Don't need Kong. Be ramp. Sure, I'll take it. That's probably good for us. Okay. Okay, if I draw land off this growth spiral, we're in business. Oh, I can't growth spiral because I don't have a green mana. Oh, I'm dumb. Okay, well, yeah, they're just going to get a big head start. Okay, well, definitely next turn I get to do migration path anyway. Yep, here comes the beatdown. Yep. My turn. Okay, let's go get some mana. Oh, hello. That's a new card. I think if I remember right, it can put its tokens and other things. Oh man, yikes! This is gonna hurt. Yeah, me not having that green mana really slowed me down quite a lot. That's a whole bunch of tokens. Yep, I don't think I can get out of this because my Kong is on the bottom. Okay, well I guess let's go ahead and Garuda. I need reach, or I need to be able to kill that. Ugh. Okay, well, all right. Screw it again. Yeah, I'm super dead. Oh, good game, Mono White. You got me. Okay, so I'm checking. I don't see any requests, so I think I'm gonna stream until I win one. That might be a few minutes. Maybe not. But I hope you guys found this productive. And if you're watching on YouTube later, please send me requests via email, and screenshots would be preferable. If you have any questions, oh yikes. Moving forward, I'm not sure I'll be streaming tomorrow, but I will keep you guys posted on whether or not that's going to happen. Your assignments, if you want correction notes, please get them turned in by Wednesday, and then I'll get them back to you so you can fix them. But work this week is going to be due on Thursday by 3 p.m. for grades. All right. Okay, so I think that's gonna be it for today. I'm gonna play my. Well, win or lose. This is gonna be my last match on stream. What you got, opponent? Okay, I'm not gonna forget to crack this. Ramp it up. Oh, cavity. So there's gonna be lots of 1/1s coming out soon. Oh, that was a really good draw. I will pay the 2 life. Let's go get some lands. All right, opponent. Let's see how many 1/1s you can make in a turn. This thing's gonna do an extra damage to me every time they attack with a creature with a power 1. So I imagine a bunch of little 1/1s coming out. Oh yeah, this one makes 2 1/1s, so she's gonna nail me for 4. They each stack, they each get a trigger, so 4 damage. Here we go. 1, 2, 3, 4. Okay. So we will fin the deck first. Get an island. We'll go ahead and Garuda. Spin the wheel, see what we get. Spark Double. Which means we get to go again. What do we get? I'm blanked. My second Garuda hit nothing. That's a shame. Yep. But now their 1/1s are kind of useless against my 6/6 and my 7/7. I mean, they'd still get their cavalcade triggers. Oh, their calamity triggers, not cavalcade. Yep. So now they'll go ahead and make the 1/1s anyway and go ahead and swing into death because the triggers will do 4 damage anyway. 1, 2, nothing about it. 3, 4. Block you. Block you. Okay, I'm going to kill this thing next turn anyway. Because they don't have any blockers that I know of. I'm going to play one. They draw. Okay. 3 damage to a creature doesn't help you out very much, does it, buddy? Light up that stage. Just light it right up. Okay. Let's go and get a scry. Don't need you right now. I 'Cause 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 ' Okay, you kill her. You smash him. Put an attack. I have 1, 2, 3, 4, 5, 6, 7 mana. Oh, if I could do both, that'd be great. What do I do? Let's go ahead and put another body on the field. Jaruda it up. What do I get? Yep. I didn't come not to play Jaruda. Oh, I kept the tap one. That was dumb. But I can't. Well, I'm gonna get an untap one anyway. Thank you, Thassa. I could take another Thassa, but yeah, I guess I had to anyway. Okay, I got 3 untapped. Go ahead and play your hasty dudes. So she plays the Chandra, makes 2 guys. That'll hit me for 4, so I can go down to 6. 1, 2, 3. I've got 3 mana, so I can't activate Thassa to tap something down. Okay, so they have 1, 2, 3, 4. If they played a land, they played another Calamity, and played her, that'd be 6 damage. So I just went to putting out blockers. Okay, go ahead and play Chandra and get in your 4 damage, I guess, unless you have some other card that'll help you out. More blockers. What was that? Okay, sure. Don't need you. You're at 13? What happens if I just tap you down? Yep, I'll take a damage. Sure. I'll go ahead and tap you down. I'll take a damage. Sure. 13, you say? Well, there's 13. Go math. You're 0. Good game. All right, everybody. I'm going to end it on that. So I will see you next time.